And so in this class I'll mainly summarize the points that I discussed in the last class, and I'll talk about the some of the manipulators in C++. In fact, there are many others which you can always refer to different tutorials, and I'll consider some examples using those manipulators, some problems. Okay, so before I start with manipulators, so the points that we mentioned in our highlight in our last class regarding the differences between C and C++. So there are a few like 6 or 7 points that we talked about, and the first one is the commenting style. So we'll start writing some C++ codes in this class. So the commenting style, we can see both the uh, single line and multi-line commenting is allowed. Header files are class and object libraries instead of just merely function libraries. And we found that cout, this itself is an object, predefined object, and apart from that there are other useful functions also available. Some other classes also are defined. Then it is a strong type check compiler, so we should not skip uh, or we should not take it in a casual way while mentioning function prototype or while specifying the type of any parameter, because it uses the polymorphic interfaces, and which the differentiates it differentiates mainly based on the. Okay, have you switched on the recording? Is the recording on?
Yes, sir.
Yes, sir. Yes, it's on, sir.
Okay, fine. Uh, So next is the predefined objects. We found that using C in Cout, we can write easy, compact, safe, and adaptive way of managing. This is one way of managing input output. We call it adaptive because we can extend the C in Cout, the use of C in Cout for user-defined data types also, like matrix, complex class, trees, or any other kind of classes that we define. And the typecasting is both the flexibilities are there. This is a new type of typecasting that is allowed. Cascading is one important feature. We can use multiple uh, insertion or extraction operators in a single line, so you don't have to write separate cout, var, cout, sent, and all this. So this is one advantage. Another is the uh, declaration of the variables are flexible enough. We don't have to always do it in the top in the declaration block. We can do it whenever it is required for the first time. So these are some of the things that we identified. So like manipulator, I mean, in mechanical manipulators we know that it manipulates it, say robot manipulator, robotic arm, like that. In C++, our objective is to talk about manipulators for manipulating outputs or the input output streams. So manipulators are special functions designed to be used with insertion extraction operators on stream objects C in Cout. Okay, so one example that we found in our last class is endl. So this endl is equivalent to /n, right? So this takes a cursor to the next line. So in C++ we can use /n and also endl. /n is just a new line character, but endl is a manipulator. So we have used one manipulator. Now in this class we'll be talking about few more manipulators, and we'll see that how this will be useful to display the outputs in the screen. So this is used to change formatting parameters on the stream, and this is important. So every manipulator, in the next slide we'll see the some list of useful manipulators. So here we see that the range. So the range of a manipulator means there can be 3 possible options, and each manipulator is defined with a particular range. So this is now, next, and all. So now means uh, when we use the manipulator, it has got an immediate effect at that particular point. like this end L. So end L means the effect means immediately at that particular point the new line character is inserted or the cursor goes to the next line, and the effect of end L is not carried forward, so it is just at that point only. Next means it affects only the next data element. That means if you call the manipulator at a particular point of time, this is meant that it will have some effect to the next data element that you are going to display. Okay, so now means immediately at this point. Next means if you call it here, it is meant to affect the next output. Okay, and all means if you call the manipulator at this point, so from this point onwards whenever you display something, if it is somehow going to impact, so it will have the impact till you uh, discontinue it or till you override it. Okay, so we'll see that how it exactly works. So let's just go through the manipulators, some of the manipulators. So this is endl. This has got the range now, and it will flush the buffer, and it has got the similar impact of slash n. Set wn, set w means it will set the, so this is next. So set w means if I call set w, there is nothing. So if you just call set w, nothing will happen in the output screen. But if you call set w and if you try to display some values, then it might have some effect on it. So it sets a minimum field, sorry, field, there's a mistake, minimum field width on output. So if I set, if I write set w 10 and if I display the value 12, this means in the output, so it will have, so instead of displaying 12 right here, it will display 12 somewhere here. So the w means it will be so there will, it will set a width of 10 characters, and this 12 will be appearing here. So definitely 12 will not shift automatically, so 12 will actually appear here. But if I want to move 12 uh, as if it is right adjusted, then we can write here set w 10 right, then 12. So this will have this impact. So it has set width of the field width of 10, and this 12 will appear towards the right. It is right adjusted. If you default is left adjusted like this, and if you don't give the uh, set w like this, so this will be just like normal 12 14 like this. So set w we'll see with examples. So whenever we display something, so if I want to display 12, then 14, then 16, so with some leading spaces, so we can call set w and we can display the values. Okay, so every time you want to display, so to have this effect you have to write set w, say maybe 4 12, then set w 4, then 14, then set w 4, then 16. So what it means, before displaying 12 it has set a width of 4, right? And okay, maybe we have to insert here the right, this manipulator also, this right manipulator here, here like this. Okay, if we do that, so out of these 4 characters it will be right adjusted to 12, and then out of these 4 width it will be right adjusted 14 out of this like this. So this 12 14 16 will have some leading spaces of 2 characters in between, so it will be separated. So accordingly we can format as it is required. Set field, instead of leaving it as blank, if we want, say the same thing, if I write set w 4, then write then set fill asterisk, then 12. Are you getting me? Hello? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yeah.
sir.
Okay.
Yes, sir.
So in this case, what will be displayed? So I said that the width should be set to 4. So 4 characters may be displayed. It is right. And then the set fill means whatever portion this value to be displayed is filling up. So it will be filling up 12 like this. The rest of the characters will be filled up with this whatever I am passing here, set fill. So it says that within the, as it says, a value does not, if a value does not fill entirely a field set by set w like this, if this 12 is not able to fill up all the 4 characters, then the character ch is used to fill it. Character ch means in this, if I use set fill, this character is going to fill it up like this. If it is left at just, so then what happens, then 12 and then like this. So in the width, this way it fills up. But if I display here 1 2 3 4, then what is going to happen? In the same example, if I use 1 2 3 4, then what is going to happen? A width of 4 characters. How
So
many?
1, 2, 3, 4 will be printed. Not the
Yes,
stars won't be printed. The stars won't be printed, sir.
yes,
Only 1, 2,
because
3, 4.
1 2 3 4 is enough to fill it up entirely, right? So there will be
Yes,
no
sir.
leading or trailing spaces which need to be filled up with the set fill. So it is just like, because we don't know what will be the output here, we know it's a constant, but generally we will not know the contents of a variable. So if we know that the variable may be so what mean the maximum size or the minimum size, we can accordingly specify the set width. And then if I want, I can fill it with dots or characters or hyphens or sometimes blank spaces, whatever. Okay, so these are sometimes very handy. We'll see within a short while how to use these features to have nice outputs, right? So here in this example, you see cout set w3 set field 0 and 7 endl. So in this case, you have set a width of 3 and 7 is filling just one character, so it will be 007 like this. So set precision, now this is all. What does it mean? So the effect of set fill this is not limited to while displaying 1 2 3 4, right? So again, if I use after this statement, if I use set w say 6 24, then what is going to happen? So I've used a set fill here, but the impact of set fill, it continues because it is forward till you reset it. So here if you call it, if you try to display it, so it will be displaying 1 2 3 4 5 6 like this. Okay, so this is the impact. So set w will have just a next impact immediately, but the set fill will have an impact throughout. Okay, so you have to just check these examples of your own, so that you know that this is what happens. And then set precision means if I am going to uh, display something like 1259.94 or some floating point value. So it will, this value of n will specify that how many digits after the decimal will be actually considered or displayed. Okay, so larger the value of n, the higher the precision will be. So then these two are very simple, so fixed and scientific. So a floating point values can be displayed using a fixed point notation. Fixed point means, so here in this case, the default precision is only a 6 digits. And if you don't want all the 6 digits, you can always use set precision to specify what is the level of precision that you want, 2 digits, 4 digits, whatever. If you use a fixed point means no matter how many digits are actually there after the decimal point in a floating point value, it will consider only 6 digits. In a scientific format, what is a scientific format? exponent format like that. Okay, so e to the power plus minus like that. So exponent mantissa kind of format. So that can be used. But all of these, I mean, from this point onwards, these manipulators once used remains, the effect remains until unless you change it once again. Okay, and this set base, it is easy to understand. It will set the base of the number that we want to display. So here the value of n can be 2, 4, 6, 8. It can be any other values also. Any integer value you can specify as n. So the nice thing that happens, say in case of C, if I would like to have a display of in a hexadecimal format, this is I think there are some format specifiers, right? In C, are there specific format specifiers for octal, hexadecimal and all? Can you recall that?
Yes, sir.
But if I would like to have a display in uh, say base 5, is that possible in C? If I would like to display a number in base 5 or say base 6, is that possible? Are there any shortcuts, format specifiers in C or say base 9? Is it possible?
I don't think so, sir. I'm not very sure, actually.
Yes, there are not standard format specifiers. So the only thing is you have to then convert the number and then store the digits and you have to display it. But in C++, it is very handy. So you just specify the value of n here and it will display it in that specific case. You don't have to actually convert. So the thing is, number remains the remains the same in the memory. It is stored in binary, but while you are displaying, you just ask the manipulator to display it in a specific base without changing the actual number in the memory. So that becomes sometimes handy. And then hex, oct, dec. So these are standard bases which you can always use, but they all have the effect of all. So let us see that how it works. Okay, so these manipulators, apart from endel, so there are so as you can see here, there are some manipulators like this one, or say this one. These are having some arguments. So these are uh, really looking like functions, because as I mentioned that manipulators are special functions. So they are looking really like functions because they are accepting some arguments also, right? And there are that, and so this also, and the rest of the manipulators shown in the example, they don't take any arguments. So whatever is the case, it is, so there are most of the manipulators are defined in iomanip.h. So iomanip stands for input output manipulator. So if I include it, so all the list of manipulators will be allowed to be used. So now just focus on the code. So we have got float x equals to 0.1, float y equals to 1.0, and z equals to 1234.0, and then a equals to 15. Now look into the first particular first statement. See out, it is cascaded. Okay, see out x, then I gave space y space z. So a normal display. So this is a normal display as usual. So it's 0.1, then 1, then 1 2 3 4. If I use a fixed, if I use a manipulator called fixed, what is going to happen? Fixed, what we just now mentioned.
Sir, it would like maintain a certain number of significant figures, decimal places.
So number of digits after the decimal is fixed to 6. No
Yes,
matter
sir.
how many are there, or even if it is fewer are there, it will fill up with 0. So it will exactly, you see, all the values are displayed with 6. Okay, so even 1 2 3 4, it's filled up with all zeros. So that is what it means. So it's a fixed point notation. Then the scientific, if I use scientific, then it is exponent. So e to the power minus 0 minus 1 and this say to the power plus say 0.3. So exponent mantissa kind of format. So sometimes it is required because a number with having a very high precision may be better understood or read using these scientific notations, right? Or a very large number, very small numbers and very large numbers are generally displayed in the scientific notation. Now the set precision. So set precision now, instead of a fixed number of digits, we can set it to 20. So set precision 20 means, now you see I'm displaying the value of x. So what is x containing? 0.1. So 0.1, and so this is the value. So the precision is 20 digits after the decimal. Okay. Now what is the problem here? Why it is displaying in this format, e to the power minus x minus this? Why I am not getting in this format? Why it is showing in this format? You see scientific,
Sir,
the
scientific calculate range of all.
yes, so scientific
Also,
is off. So that's a problem. So if you have not noticed it, so you find that okay, I just want 20 digits after. So what probably you would have expected here is 0.1, then 19 zeros, right? But it has displayed in some different formats, scientific. So until unless you convert it back to uh, the normal one, like the fixed point or whatever, it will keep in that mode. It will remain in that mode. Now the set w means you have set a width of 8. Now fill, so if it is unable to fill up, it will fill up with asterisk. So what it displays? So 34, you see total 8, the last two is filled up with 34, and then after that it is 48. So 48 comes immediately afterwards. Why? Because set w, you see it's just having a next effect. Sorry, it's having a next effect. Set w is next. So the impact of set w is limited to only this displaying of 34. But this 44, 48 will be just displayed afterwards. If you would like to have the impact of leading asterisk before 48 also, you have to write set w explicitly, because set w has got a immediate effect like this. Immediate effect. Just a minute. ক্লাস নিচ্ছে কিন্তু খেলতে গেছে না আমি আমার ক্লাস চলছে তো তুমি খেলতে গেছে খেলতে গেছে sorry sorry for the interruption. Okay, so as you can see here, set w 34 and set w 48. So if I would like to have the impact before 48, so this is how it is done. And what happens here is the set fill, so they have got the next effect, right? So they have got the next effect, but this set fill has got the all effect. So that's why, although you have set you have passed the parameter to set fill here, this has got the effect here also and here also. Can you see? Is
yes,
that
sir.
fine? So the thing is, you should be a bit careful, otherwise what you want may not happen here. So just so that's why it is important to know the range. This is important, not only just how to use it. Otherwise I mean, you may
Sir,
end up.
how do we reset it, sir? So
Hello.
how do we reset it? So how do we reset the all range
No, no, you have
manipulators?
to just, you have to then again call set fill with blank, so it will be again, because maybe the
Okay,
default is blank or whatever you want
okay,
to
okay,
do.
okay, sir.
So like that will, now once you set it with some other values, so that will remain for some time like that. But it is always dangerous to use alls, because I mean, you have to every time reset it if you would like to change it. Otherwise that will carry forward. Is that okay? So now this hex of a, hex means the value of a is 15. So if I write hex of a, so it will just display f. So you don't have to. So the nice thing that happens here is you yourself don't have to convert this 15 to f. So 15 automatically gets displayed in the hexadecimal format, but there is no impact in the contents of this variable a in the memory. Okay, so this is how it works. Now if I now let us write a very simple piece of code. If I would like to have something like this, okay, so how many lines are there? 3 lines are there, and say this is the monitor. So if we would like to have this displayed, so how can we do this using, so if I use simple C code, how many loops are required to get it done?
So two
So two
nested
loops.
loops. Are,
Two nested loops, right? Because one loop, there will be one loop that will be controlling the lines, and within another loop nested within it, that will be controlling the characters within the line, right? And we can count how many are there. So will that be okay? Will this be okay to display this pattern? Just two loops, will this be okay for this pattern in C?
so I
Consider
guess
the
we need.
spaces, sir.
Hmm? Hmm?
We need to consider
So
the
yeah,
spaces.
yes sir, yes sir. The spaces,
So
sir.
how many loops will be required?
So
So two
three.
only,
So
but
total four loops will be required.
In total, how many loops will be
acha,
required?
in total, three,
Four
sir.
for loops.
Hmm?
Total four for loops. One for the outer loop
Hmm.
and three nested. One for spaces. One for the left stars and one for printing the stars to the right of the midpoint.
Okay, can't we manage all the stars in using a single loop? Number of
Yes,
stars.
sir. Yes, sir.
This is possible, right? Because you are not displaying numbers. So you are, so in the first line you have got 1 star, 3 star, 5 star, 7 star. So if the value of I, so the thing is this one is actually controlling the spaces, the leading spaces. And then there will be another for loop that will be controlling the display of the stars, right? So if I write I equals to, so I think you people can do it. And how many leading spaces will be there? So in such a case, what I do, we basically try to decode the logic for the ith line. So this is say the ith line. So in the ith line, what happens? There are some leading spaces followed by some asterisks, right? So how many leading spaces are there? So if it is the ith line or the ith iteration of the loop, so how many leading blanks are there? And
N
how many,
minus I.
hmm?
N minus I.
Is it n minus I?
So if I begins from 1, then it is n minus I. Otherwise, it is n minus I minus 1.
Okay, so it is n minus I, say for example it's n minus I, right? And how many characters are to be displayed in the ith line? If I equals to 1, it is 1. I
I.
equals to 2, it is 3. So it will be 2I. What will be the
Minus
value?
2i minus, mean 2i minus
2I
1.
minus 1.
2I minus 1, right?
Choice.
So that way it can be done. So we can manage it. Now if I would like to do the same using manipulators, then how you would have done? So same, the logic is the same. Now can we do something better? For
So the space will be controlled with
now you
set.
see int I can declare I right here because of the flexible declarations, right? So I equals to 1, I less than equal to n, and I plus plus. So here, so I am encoding here the logic for the ith iteration or ith line. So what happens? So what should I do now? So how many loops in C++, if I would like to use manipulators, how many loops do I require inside within the outer for loop? So how many loops will be required here?
Sir, one loop.
One loop will be enough. So any other answer? How many loops will be required here? Required. Hello?
Just one outer loop will be fine, sir.
Then what about the innermost logic, inner logic here? How do I manage it? So first of
We are
all,
managing
so
that through the set
so
W and set
so
fill.
again, if I refine my question, so how many loops together altogether it will require? So if it is C type coding, we require 3 loops. If it is C++ using manipulators, how many loops are required in total? Hello? Any answer? You are trying to answer. So what is the answer? Somebody, I cannot see the faces, neither I can see the names because I've switched to the full screen. How many loops will be required altogether? Hello?
Sir, I think
Sir, I
it
think
is.
One at a time? How many?
Sir, I think it will be just one.
It will be one. Any other answer? Do everybody believe
So,
that it will be one?
so same, so one. That's what I'm
Yes,
feeling.
because it is easy to understand, because you see I can, so to display this pattern in the ith line, so I can split it into two things here. So this can be one, right? So we can have like we can set the width equals to n minus I plus 1, right? Is that fine? And then we can fill it with blanks. That's the default, so we don't have to call set fill, and we can display this character then. So this part is done. What about the rest of it? And how many are how many asterisks need to be displayed? We can again set a width of what? We can set a width of
So 2i minus
2i
2.
minus 1.
2i minus 1. Yes, 2i minus 1. So we basically set a width up to this, right? 1 plus. Then we can call set fill with these characters, but end up with a blank character. Are you getting my point? So this will be the blank character. So generally what we do, we fill it with blank characters and then we display with some specific characters. So that can be one way of dealing with. I mean, there can be other ways also. So are you getting me? So this is A, this is B. So A part is, I write set W. What is the value? What will be this value? So the leading blanks plus including this one, I set the width. What will be the value then? Are you getting me? I'm talking to the class. Are you getting me? Or
yes, sir.
so I have divided up to this. So this part I have considered right from the beginning. So it is set n minus 1 plus 1. So then what I do, if I don't call set fill, so the default is blank, so I just leave it as blank, right? And then what I need to display, I need to display this character. So this character will be this one. Okay, so this part will be displaying the part A, as you can see here. So what is left? 2n 2i minus 1. I mean, in fact, so how many asterisks are yet to be displayed? How many characters need to be displayed right now? How many characters are left?
So
I mean
2i minus
asterisks.
1.
No,
Minus
2i minus 1 is already there already. It is
That's
basically
2i
2i
minus 2.
minus 2.
2.
2i minus 2.
Okay, so now what we can try, so now we set the width up to this. Instead of 2i minus 2, I set it to, so set W 2 into I minus, sorry, 2i minus 1. So I include this one more. set w. Then what I do?
Set fields.
I would like to actually display the blank character. So this is this. Okay, Wendell. So I would like to display this particular character, but the leading spaces should be filled up with, what is the value? How should I fill it with?
Star.
Asterisk.
Stars.
Is that fine? Will it work if I write like simply like this? Will it work? So this will be displaying the B part, and so they are all cascaded, right? So this after that this comes, and after this comes like this. It's a single statement. Will it work? Will it give the display? Think and give me the answer. Will it give the
How
display?
will we display the blank character? Backslash 0.
No, blank is just a character. It's a blank. This one.
Like
This.
set fill. Set fill can do that.
Which one?
So we can use set fill to display the blank characters, or just or alternatively stars.
Which one? When you go to the next iteration.
Yeah, no, sir. In the like, in order to display the blank characters, could we
The
just do
blank
this like?
characters, if you don't specify anything, it is default. So default is
Okay,
blank. So that's why I have skipped it.
okay, sir.
So my question is, will it work then? Say when the first line is done. So first line we have set field to this one, right? We have set field to this one. So if it goes to the next iteration, so the set field will fill it up. So here the default is not now blank. The default is these asterisks. Are you getting my point? Because of all,
Yes, sir.
once, so the thing is I have to explicitly specify here set field. Are you getting me? So you have to specify here set field blank, then this character, then set field with asterisk, then a blank. It goes so. So this need to be explicit. Otherwise, the previous iterations set field asterisk will be used here, and it will not actually store display blank spaces. Are you getting my point? All others, are you getting things? This is very simple. I mean,
Yes, sir.
you yourself, I think it is better to get things of your own rather than explaining things. It's so simple anyway. So you have to just understand the impact and all. So might be you have to write few lines and you find that it basically messes up, and then finally you come up with the actual ones. Is that okay? So now instead of 3 loops, you see there's just one loop that solves the problem. So you can have much compact and smarter codes if you can use manipulators. But the thing is, as I mentioned, like even if I forget, then this will have the impact in the next iteration. And even the first line is fine. The second line, instead of leading blanks, it will start displaying asterisks, and you will find that something went wrong. Is that okay? So let us come to something like this, another problem. So let me show you the output of the code. So this is pattern example sin x. Okay, so g++ sorry, what is this? G++. Sin exploiter. Okay, I've just commented everything here. Anyway, let me just uncomment it first. Show you the output, and so that we can later on focus on the. Okay, what it asks for. So as I shown that I would like to have the sin x, sorry, the sin x display. Okay, this Wacom will not work in this output screen. So let's just see. So 0 from 0 degree to 360 degree with a step length of 9 degrees. If I start filling with this one, now see what's the output is. Can you see the output? What plot it is? This is a plot of
Sine.
hello. This is a plot of sin x, right?
Sine wave.
Sine wave, sine function. So now if I again say 0, then 360. If it is a 4, you see again the some other characters say like plus, maybe it is dollar. Now what happens? So this is a much smoother, right? It has got a much smoother feeling. Okay, because I've increased the steps in that range. So this is what I want to display using the manipulators. I write here 720, then it is 4. This is characters are say this one. You see, this is how it appears. So we can basically visualize any kind of mathematical function, trigonometric function, say sin x, cos x, whatever. So, and if it is say cos x, I just have to make change here. Zero, 360, and 4. Character is this. Now can you see which function it is displaying now? Cos x, right? So any function that ranges within plus 1 minus 1, we can display it. We can also try it for damping oscillations or whatever, e to the power minus x sin x and all this. So this is what I want as output. So now let's get back to the writing of the codes. Okay, so this is can you think of it how to approach? So this is what the output I want. So I want something like this. Can you get me the logic? How many lines of code are required for this? Can you try to visualize how many loops, how many statements within the loops? Hello, have you got the output? Have you got the problem?
Yes, sir.
We'll get into the details, but can you before that, can you tell me how many loops are required and how many might be that we have already found it while I'm modifying, but anyway, so can you figure out how many loops are required and how many statements within the loops? What are the key statements? How many are required? Every time you just think of the, so how many lines are there? How many lines are there like this? So you just take into the ith line, right? So in the ith line, what happens? You see in the ith line, what can be the two possibilities? One thing is you are displaying the positive value, it will be like this. You may be displaying a negative value like this. So you may split the problem into two cases. So one is this case and this case. So it is a case 1 and this is a case 2. Sorry, this part, case 1 and case 2. Is that fine? So now can you tell me what is case 1? Any ith line in the case 1 and any ith line in the case 2.
For the case one, we need to print the blank spaces, appropriate number of blank spaces, and then print the number of stars according to the value. And for case
That's
two,
all.
it's
Hmm.
and for
So,
case two, it's simply printing the number of
so
stars.
first of all, can I do the display of a ith line in case 1 using a single cout cascaded statement? How many parts it has got? Part A, then part B. Are there any other issues here? Are everybody can everybody follow? Others, those who are not responding at all?
Sure.
See, so this is no C++, this is no object oriented programming. I just illustrated the use of manipulators, which are special functions, and you have to just write a code to obtain this output using those manipulators. It's just simple logic. So there is nothing at all, and there is no prior knowledge required. So anybody can participate and they can comment on it. So those who know Java, those who know C++, Python, doesn't matter. So it's just simple logic. So first of all, I would suggest, like, I know that there are many uh, good programmers who are already quite acquainted with writing codes and all, and there are few newcomers, like those who have started serious coding maybe a year back. But this is not the major issue, I think. I mean, there are many examples that I experienced in my teaching career, that those who are the first time coders at the end of 3-4 years, so they are far ahead of those who have started pretty early. I am not just trying to demoralize those who have started early, but this is what happens, because after all it is purely logic, and if you are serious enough you can. So this really hardly matters. In fact, in our days we never saw a computer before entering to the college, so that really is not a major issue. So just tell me the logic. So in the case A, how many, so in the ith line, how many components will be there? A and B. Is that okay?
Yes, sir.
And in case B, how many components will be there? You see? So that we don't have to, we can ignore this part, right? So if I look into this part, how many components are there? This is also A and this is also B. Or say maybe C and D. You can write C and D, right? This is C, this is D. So now what you do here is basically, and how many lines will be there? How many such lines will be there? Hmm?
So upper limit minus lower limit plus one.
So I equals to say it is say A, I less than equal to B, and then I plus equals to S, right? S is a step size, is a steps. So if it is a 0 to 360, and if you are every time you increase by, so what is this? This is 0. What is the degree here? What is the degree here? This is 0. This is what?
So 180.
So 180.
It is 180.
180,
This is
sir.
360, right? So this is 90. So now can you just try to guess that how many values should be good enough for visualization? So total 360. So total 360 means this much. So total 360. If I so by 2. So how many lines? How many lines do you expect in this half? How many do you think? So within say 90. So this is 90, right? So this much is 90 degrees. So within 90 degrees, how many do you expect? So if I divide 360 by 4, how many do I get? 40. So 40 means 20, 20. So this is 10. So 10 values will be here. I think that will be good enough, right? Are you getting my point? So the step size, if I set it to 4, 360 by 4 means, so it will be 40, total 40. From here to here it will be 40. So from here to here it will be 20, and here to here it will be 10. You can always increase it, you can reduce the step size, or you can increase the step size. So this is the case. So we'll be taking input A, B and S, say for example, and then within this, what is going to happen, we'll have the value of, say if it is a sine plotter, so sine of what you need to calculate, sine of what is this I, what is this I,
So degrees.
so this is the degrees, right? So this I is basically the degrees here.
Theta.
So theta or whatever you can, so you can call it as theta also, th, you can write here th. Okay, so sine theta, whatever you get, what will be the value, sine theta will be -1 to +1, right?
So
So
don't
this
we need to
means,
convert it to radians? Yes.
yes, that will do. So sine theta, so sine theta, that the library function sine x, what units is value of x is, can you check?
Radians.
In
So
radians, you will
radians.
see that if I type manual pages, man sine x, so they will find that it accepts x in radians. So if it is x in radians, so theta should be converted to radians. So what should I do, theta into
Sir,
pi by 180, is that okay?
yes, sir.
So if, so that means when I input the values, I expect the user to input in degrees, because that is much easy to understand. Input in degrees, and you basically specify the step size also in degrees, but when you compute the sin x, you convert it to radians, right? So this is radians. So sin theta, so it will return either, so in a range of +1 to -1, right? So this is the range. Now what should I do now next? So now in the screen, say in the screen here, how many characters can you display in a single shot, in a single line? Have you ever checked? Definitely the resolutions might differ and all this, but trivially, I mean, generally how many characters you can display? How many characters? We'll see that it is almost nearly 120. That also you can make a small experiment. You write a for loop and you try to display 100 characters. You try to see whether it fills up. You write 110, 120, 120 more or less fills up. So if it is 120, then you know this should be the axis where theta is increasing. Is that okay? So how many, so what will be the width of this here? So what do you think should be the maximum width that you allow? So
So
60,
60.
60 or
60.
less.
no, 60 will be too much, so it will be better be restricted to 55. So 55, 55, right? So you accordingly plan it. So it is 55, it is also 55. So when it grows in negative side also, it will be like 55, like this. Okay, not be simultaneously, it will be here. Is that fine? So if it is a positive half, so first of all, if I get any value in the range of -1 to +1, what should I do now? I should be multiplying it by,
50.
I can multiply the value with 50, right? I can multiply the value with 50, sine theta into 50. So that means the value whatever I get will be scaled in this range, right? Now once it is scaled, now what I need to do, I need to basically, when it comes to this part, negative part, so what means, so there will be some leading blank spaces, okay? And then what I do here, I mean, forget about the leading blank space. So what I mean to do is, say set w55. So this total set w55, what I do, if it is this case, negative case, what should I do now? In the ith line, in this ith line, what should I do now? So this is a C, this part is C, and this, sorry, I mean, this part is blank part is C, and this part is D, filled with asterisks, right? So how many leading blanks will be displayed? Set W, how many
55.
will be displayed? So what is this value? How many characters need to be displayed here? how many characters need to be displayed? See, this sine theta or sine theta in radians into 50, whatever it is, if I convert it into floor, I'll get an integer value, right? Let it be x. If this is x, so that x is the number of characters that I need to fill it up, right? Because if it is -1, I need to fill up with all 55 characters. 55 these things, right? Are you getting me?
Yes, sir.
Now, if it is not exactly -1, the extreme negative value, that means it will be something like say 30 or 32, whatever. So this value of x is this one. So how many leading blanks should be there then? It should be set w 55 minus x. Is that okay? Are you
Yes,
getting
sir.
my point? So the value of x here, whatever I get, is the number of characters that I need to fill it up to have that visualization, right? At most, if it is -1, it should be 55, so it will be all filled up. So if it is not the maximum value, then it will be 55 minus x. Is that okay? Is that fine?
Yes,
Yes.
sir.
Yes, sir.
And then what is the d? D part is, so what do you need to write? So cout set w 55 minus x, then it is set fill. How to fill it? How to fill it up? Set fill using blank because it's leading blanks. Then what I need to do, you see, in the starting I should have a plus and then asterisk 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 like this. Okay, so this will show the envelope, right? And this will be the filling patterns. Are you getting my point? So after that, what should I write? So this will take care of, so this much will take care of this much. Is that okay? The leading blanks followed by uh, the periphery of uh, that visualization, that plus symbol. This one, I'm talking about this one, this much, this one and this
Hello,
one.
sir.
Yes.
Sir, what if we don't place that plus? If we don't want to place that plus and
No,
we
it
just
is
want
just
to
like
place.
I just placed it. It is up to you. So it just shows a nice. So there can be different symbol. I may not place it also. So this is not mandatory. This is just what I did. That's why.
So, sir,
Okay.
we can have another set W again instead of plus after set fill.
Yes, that is possible. That I mentioned. So, but I would like to have an envelope with pluses and filled up with these things. So you can skip this also. This is not mandatory. But this is what I have planned because this is a visualization that I have thought of. Okay. But you can always use different characters and you can just remove it and fill it up with just asterisks. That is possible. So after this part is done, what about this part? What I need to write? As we was telling, set w. So I'm trying to encode this d part, this part. How many blanks? Set w.
Sir, sir,
Hmm?
X
X. Then fill it up with set fill.
starts.
So there should be x minus 1 set W.
Yes, you see, there are. I understand because we decided to stick to 55 and one gone, so maybe x minus one. Okay, if you are happy with that because it's fine. But set field, I can set here C. So C is a character. Okay, so character C. Because if I want, so that is a character that I was entering every time. So it can be a dollar symbol, it can be asterisk, it can be minus or anything else, a dot. Okay, so the filling patterns, the character and the filling patterns can be entered as an input. But this plus, it is fixed. Like that is how I chosen it. So then next what happens? Next what is required? So once this part is done, how to end it up with? You see, we have to use this character, like this one, the axis character, the character that denotes the axis. So this part, what do I write here? Handle. Is that okay? Is that fine?
Yes, sir.
So this part
Yes, sir.
encodes the negative portion of sin x. So the negative part, let me write So negative part means set w 55 minus x, set fill, then we have got, now as I have chosen this, let me stick to this, you may skip this also, set fill x minus 1 as you wished. So this is sorry, set w, this is set w, then set fill with the specific character that we have entered, then this character, then endl. Okay, so this will demarcate the axis, this one, this line. So what about the positive part? Now can you write the positive part? Now this part will be something like this, right? So when I talk about the positive part, so this is the screen. So positive part means this is the positive part. So what are the parts here? So this is A and this is B, right? So how many blank spaces should be there? Set W, how many of them will be here? Set W 55.
55, sir.
Then what next? Then we should have a this character, right? Then what next? How many characters? So how to display this B part? B part should be set W, how much? This is
X
X. So set
X.
WX, then filling out with set fill.
plus
No, set fill
star.
C. No, C. We have did. So
C.
it can be anything that we enter. So the filling patterns can be anything. Set fill. Then what next? As I decided, I should end up with this plus.
So
Then what
here
next?
also we should make x minus 1, sir, because
Okay, x minus 1. Okay, fine. Is that one? Is that okay? So just write it here. So set W 55, then set fill, uh, sorry, then set fill this, then this character, then set W X, then set fill C, then plus, then handle. So what I do here is I just check if x is greater than equals to 0, I do this, else I do this. Is that okay? Is that fine? Will it
Yes,
work?
sir.
Will it work? Think and answer. There is a small piece that I have missed. Try to find it out. Something I missed here in the negative part. What is that? What is the value of x if it enters here? The value of x is minus,
We
right?
need to make it positive.
So how to do it? X, absolute x, right? So it's basically takes absolute value of x, abs of a, then it works, and there is nothing else required. So how many lines of code? How many lines of code? 1, 2, 3, and then 4. 4 lines of code, right? This is how it works. So this is 1, so this is 1, this is 2, this is 3, and this 4 loop. That's all. And this one I have entered. Can you see? Can everybody see the code? This is visible.
Yes, sir.
So this actually encodes this line. This portion encodes this line, this portion in every case, and this actually encodes this portion. And this for loop actually denotes how many iterations will be there. This is a step size and all this. Is that okay? And we are accepting the initial range, the final range, the step size, and the filling character. Now let us get into the code and we see that how it works. So this is the code, and we have already found this how it was working. So it is 0, 360. And if I reduce the step size, say 12, it will be very short. And then if it is say dot, you see these are dots filled up with dots. It has got very few number of lines in between this, and this is still a cosine plot. Is that fine? Hello? So if it is
Yes, sir.
2000, and then this is say say 4, and this is say asterisk. Now you see it scrolls up, and generally plotters are like this. So earlier days there are plotters which are having rolls of those sheets which keeps rolling, and the plots keep coming. So this is the time. So in this direction we have the time, and or say the theta, and this direction we have the values sine theta. So is that okay? So this is one example of manipulators, and you see that how using manipulators things become so compact and nicely organized. So just 3-4 lines of code and you have these nice patterns. So now can you do it for damping oscillations? Can you replace the formula with this? Hello? Hello?
Yes, sir.
Yeah, so the only thing is the formula that you write, you have to just check the maximum range and the minimum range. And accordingly, if you think that, or if you find that the your application is not having plus and just only the positive values, so you can always adjust it like this. So maybe you have to write a different piece of code for functions which are having only positive values, functions which are having only negative values, and functions which are oscillating positive negative like that. And instead of 10x, you can truncate the value so that it never goes to the infinity like that. So any kind of function, trigonometric functions, can be visualized using this. Is that fine?
So truncation using modulo operator or something else?
So truncation means you don't take, because you know that tan theta can go up to infinity, plus infinity, minus infinity.
Yes,
So you just consider, say I'll consider a value up to say maybe say 10 or 20. So you just deal with a finite range, because you know it is basically going asymptotically towards that range. So you just say that tan theta, I'll be displaying the values only within a finite range, say plus 20 to minus 20, that's all. So accordingly you scale it, the values that you get with every increase in theta. Okay, you can display exponential curves also. Okay, so one more assignment that I just give, I'm not discussing anymore, so I'll end the class. So it's like generally whenever I write codes, you can see here these are indented, right? Indentation, so we have got some leading blanks and all. So this is indentation. So if I give an unindented code, so there are no leading blanks in every line and it is not properly readable. So you should write a file. So you should open the C++ file, you should read the lines of that file, and you should insert leading spaces. And if it is a starting of the parenthesis, you just add say four leading parentheses. Now if it is nested within this, so 4 plus 4 like this. So as you have more nesting, you will have more leading spaces every time. So when you encounter a closing parenthesis, then you reduce the number of parentheses count, number of uh, say blank characters count accordingly, or tab count, whatever. Are you getting my question assignment?
yes, sir.
You open a file, a standard file, C file, which is not indented. Open it, read the lines one by one till the end of line, and then try to parse through that. Try to find out the opening parenthesis and closing parenthesis. And accordingly, you insert some leading spaces. And using the set W and all this, I think you can manage it. And then once it is done, the refined character. So each line is treated as a string. So that string is copied back to the file. And when you open the file in a text editor, you see that it has been indented nicely. So you just try to write a utility using that. You have to know string manipulation or character manipulation, and also find file handling, text file handling in C++. You can just stick to C concepts also, like simple C, fopen, and fread, and all this, and fprintf, fscanf.
Sir, FR open.
Hmm? Hello?
So wasn't it FR open, sir, for reading the
Which one?
contents? So for reading the contents of a file, the command was
Yes.
FR open.
No, you can just use fscanf, fprintf. For the
Acha.
timing, I am not going to the C++ type file handling. Let it be C type file handling. That is good enough, because I just want to see that how efficiently you can write codes and all. Okay, so I'll put this in a assignment, but for the time being, you just try to try these things. Try to write this utility. This is one. Another is integers has got a maximum range, right? Because integers cannot be too big, can be represented here. So long int and all this. So if I want to add, say, two integers, or one integer of having, say, 10 to the power 9 digits, and another integer 10 to the power 9 digits, is that possible? Can we represent those integers using a particular data type, inbuilt data type in C or C++? A integer with 10 to the power 9 digits, can it be
No,
represented normally?
no, sir.
No,
Hello?
sir.
No, sir.
No, sir. No.
So try to represent it as a character string, right? Each digit is treated as a string, as a character, and treat the entire string, entire integer as a string. And then, like manually we carry on the addition, try to add it and get the results. So the things will be too big, so you have to probably store the first number in a file, second number in a file, and the third and the resultant, the sum, also in a file. So long ints kind of thing. So you can use the addition to multiply, and multiplication to kind of to find out factorial. Do you know how big a factorial can be calculated in C or C++ in a normal way? Have you ever calculated factorial 24, 25, 30? Do you know how many digits are involved there? It will simply blow up the storage space, I mean the maximum limit of integers. So to have a factorial of, say, 100 or 200, there is no other way other than treating the integers as strings, and then carry on like manual type. So you have to write the algorithm the way we carry on the calculations manually. Getting my point?
Yes, sir.
Hello?
Yes, sir.
Are you getting
Yes,
me?
sir.
Yeah, I'll put it in the assignments. So this much for this class. If you have any questions, you can ask me, or otherwise. Do you have any questions? Any questions? So now we have we are already past that introductory phase. Now, because it's a programming class, we have to start programming. And those who have not done C coding that much, so still you can restart from C++. If you just know the basics of loops and all, it is good enough to start afresh. So I would expect everybody to write codes, and write as many codes as possible, because you are computer science students. So this is the main thing that I mean, we need to do throughout our career. So I'll put some assignments. There will be some compulsory assignments, and there will be some optional. So those who have finished it up early, they can try those ones. Any question?
Sir, when will you be uploading these slides, sir? Like the programs and the different manipulator slides?
Yes, I am doing so. I mean, already the previous classes lectures I've already done,
Okay,
right?
sir. Yes,
Are
yes,
you
sir.
not getting things? I mean,
No, sir, no, sir. You've sent it in our mails, right?
yes, through the mails I'm forwarding. So these lectures
Okay, sir.
you will be getting. Still, I can pass it on the slides as well as the codes.
Okay,
And
sir.
along with that, the my scanned notes from some uh, long back that I have taught. So one notes I have preserved. So those few pages, I'll the PDF I will pass it on. because these are very basic things, and I don't think you can follow any book if you wish. Apart from Bruce Ekel, you can follow Balguru Swami or Kanitkar or whatever you feel like. The materials I'll pass it on. There is not a problem. Is there any other questions?
No, sir.
Hello.
No, sir.
Okay. So then I leave the meeting room. Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.